Now there is one last interesting topic, which is going to be angles of intersection. So given that we've already talked about lines as well as planes, suppose that we have two of them intersecting each other and we're interested in finding the angle of intersection. Now with that in mind, suppose that we have a line and another line that happen to intersect each other. As of right now, we know these things to be in terms of their points and their direction vectors. So suppose that we know one of the direction vectors and we know another direction vector. Well, we know how to find the angle in between two vectors. What we don't know is whether we're going to be finding this little acute angle between them or this big old obtuse angle that's between them. Now regardless, the dot product is capable of distinguishing between an acute angle and an obtuse angle. So what we'll do is find the angle between the direction vectors. If the angle we get is acute, cool, we're all set. If the angle that we get is obtuse, then subtract this result from 180 degrees. That will give you the acute angle that's between them. Now, if you're interested in finding the obtuse angle, all that you need to do is reverse these two. If you get something acute, subtract it from 180, and if you get something obtuse, then you're all set. Now, as far as a line and a plane is concerned, suppose that we have a plane. And we get to kind of force some perspective on this one. We know that within this plane, we have a corresponding normal vector. We'll draw that so that it goes straight up. But suppose also that we have another vector that comes in, or excuse me, a line that comes in and intersects the plane somehow. What we'd be interested in doing is projecting this vector down into the plane and calculating this angle right here. Well, given that the plane is defined in terms of its normal vector and the line in terms of its direction vector, what we could do is start by finding the angle that is between the vector and the line with the knowledge that this is going to be 90 degrees minus theta. However, what we don't actually know is whether we're going to be dealing with an acute or an obtuse angle when we find that angle. So it is entirely possible that you could also be finding this angle right here. Now, in order to figure out what this would be, we'd have to subtract this angle from 180 degrees. That would leave us with 90 degrees plus whatever the angle theta is. Additionally, if we were to continue this vector in the backwards direction, I'm pretty sure that we would get that this angle right here is in fact theta. So with that in mind, we find the angle between normal vector of the plane and the direction vector of the line. The result will either be acute or it'll be obtuse. If the result is acute, then what we're going to do is subtract from 90 degrees. That'll give you the angle of intersection between the actual plane and the line. If the result we get is obtuse, then you are simply going to subtract 90 degrees. So if what you get is obtuse, you officially have 90 degrees plus theta, subtracting 90 degrees, and you will be all set. Now, as far as a plane and a plane is concerned, this one's a little bit more complicated to draw, but we're going to try it, and then we're probably going to fail, and then we're going to try something else. Oh yes, already looking quite questionable. So, you know what? Imagine that you're looking at the intersection of these two planes down one of its corners, so that all you can see is this side of the plane and this side of the plane. Well, then you know what you have? You have the intersection of two lines. And we basically already know what we're supposed to do there from the first case. However, unfortunately, we define these planes in terms of their normal vectors. So the question becomes, how will those be related to each other? And the answer is, well, exactly the same as what we saw for the lines up here. Now, the normal vectors, you'll either get something obtuse or something acute. If you wind up with something obtuse, then you subtract it from 180 and you're all good. So find the angle between the normal vectors. If the result that you get is acute, speaking of acute, I'm sitting right next to a cute cat right now. If the angle that you get is acute, you are all set. If the answer that you get is obtuse, well then subtract from 180 and you're all set. I hope that that's still in frame. Oh, good, it is. Excellent. So to give you a quick example of how this whole process is going to work, we are going to find the angle between these two planes. We're going to find the angle of intersection between x plus 2y plus z is 4 and negative x plus 4y plus 3z is 2. So first thing we'll do is grab the two normal vectors. Normal vector number 1 we get from the coefficients of x, y, and z respectively. That'll be 1, 2, and 1. For the second plane, we'll call this normal vector number 2. That'll be negative 1, 4, and 3. If we can find the angle between these two normal vectors and then treat appropriately, like we said on the previous page, we'll be okay. So first thing we'll do is find the dot product of each of these. Find the dot product of the two of them together, excuse me. So same process as what we went through in our previous section. We multiplied the corresponding components together and add all of the results. So corresponding components would be 1 times negative 1, 2 times 4, and 1 times 3. I'm seeing negative 1 plus 8, which is 7, plus 3, which is 10. Next up, we'll find the magnitudes of the two vectors. Magnitude of normal vector number 1 is the square root of 1 squared plus 2 squared plus 1 squared. I'm going to try not to overthink that one too much. Magnitude of normal vector number 2 is going to be the square root of negative 1 squared plus 4 squared plus 3 squared. That'll be the square root of 26. Multiplying these two magnitudes together, which will be needed in our angle formula, we get root 6 times root 26. You can verify by actually multiplying these together yourself. We can borrow a root 2 and a root 2, leaving us with 3 and 13. 3 times 13 gives us 39, and the two root 2's give us a 2. Now the angle in between these guys is supposed to be the dot product divided by the product of the magnitudes. Now for the purposes of what I'm going to do in the calculator, I am going to simplify this. So the angle that we're looking for is going to be the arc cosine of 5 over the square root of 39. Now the good news is, I can already tell this is an acute angle by the fact that the dot product was positive, so that's good news for us. Looking for an arc cosine of 5 divided by the square root of 39, and rounded at the second decimal place, as we typically do in these videos. That is about 36.81 degrees. Now again, if we had gotten something obtuse, then we would have subtracted that result from 180 degrees. Thankfully, the result was acute, so we are done with this problem and this video. Bonus material. Can you actually see her? Oh, baby!